All right, so when we talk about exponents, we mean a number to a power or an exponent. So this number here is the power, also called the exponent. And that power is over a number we call the base. We could say 2 to the third power. Or 2 raised to the third power. Another name for this is, we call this an expression or an exponential expression because it has an exponent and a base. And these can be basically any numbers. 2 and 3 could be negative, could be positive, could be decimals, could be anything. But for now, I believe we're just going to talk about the positive powers and also positive bases. So let's say I want to find, so 2 to the third power. If we want to find the value of this, so 2 to the third, we need to first expand it. What is the expanded form of this as a multiplication? 2 to the third, what does that mean? Does that mean 2 times 3 or does it mean something else? So 2 to the third is basically 2.
Like multiplication 2 times 2 times 2.
Exactly, times 2. So we just multiply the base by itself 3 times because the power is 3. We repeat the 2 3 times. From then you can do 2 at a time. 2 times 2, that's 4, times the third 2, and you get 8. So 2 to the third is 8, not 6. A lot of people make this mistake. They think it's 2 times 3. It's not, so it's 8. So this is what we call the, so this is the exponent form, or the exponential form. This is the expanded form, and same as this, and this one of course is the value. So after you expand it, you get your value, but it's the same number, it's just written in different forms. We also see something like this. So this is 2 to the third. This one is 3 raised to the fourth power. So to find the value of this, again, we need to expand it, then multiply. It's not 3 times 4, but instead it's 3 times itself 4 times. Once you expand that, you don't have to do all the multiplications at once. Always do that 2 at a time. So these 2 turn into a 9 times these 2 turn into a 9 as well. After that, you multiply the 2, you get 81. So 3 to the fourth is the same as 81 after we expand it. And if the, could even be something even longer than that. So we have 2 to the fifth power. Again, we're going to write what is the expanded form of this expression, 2 to the fifth. We're going to times 2 by itself. How many times? 5 times. 1, 2, 3, 4, and 5. Again, don't do all at once. Try to do 2 at a time. So this is 4 times 4 times 2. Then come back again and do 2 at a time. 4 times 4 is 16 times this 2. Bring it down. Finally, that's 32. So 2 to the fifth is basically just 3 to the second. 2 to the fifth is 32. And this is very useful, especially in computer science when you study binary system which the computers use. You're going to be using a lot of these 2 to the power 0 all the way to 2 to the power 8. Okay, the bits and the binary system of the zeros and ones. Okay, so that works also with that works with fractions. Let's say you have 2 to the third, maybe to the fourth power. It works the same way. You can multiply this by itself 4 times, 2 to the third, 2 to the third, and so on. Or you can just split this into 2 exponents. You can say 2 to the fourth and 3 to the 4th. Because this power 4 belongs to 2 and 3 at the same time. So when you split it, you can write each one by itself, then you expand this one. 2 times 2 times 2 times 2 would be 16. And 3 to the 4th is here, is 81. Okay, so if the power is big, maybe 3 or 4 or 5, you can turn that into two expressions and simplify. Or it's also possible to just multiply the fraction by itself. For example, 1 over 5, the power is here not too bad, so you can say this times itself. So that's the base, and that's the power. So I'm going to repeat the base twice. So 1 over 5 times 1 over 5. How do you multiply the fractions again? In which way do you multiply the fractions?
It would be 1 over 10. Oh no, sorry, 1 over 25.
That's right. 1 times 1 is 1. 5 times 5 is 25. So we multiply the fractions straight across, as we saw in the first couple of lectures. And that's pretty much what exponents are. You expand them, and they're basically just another way of writing multiplication. Let's say you have this number here, 7 times 7 times 7. A repetitive, long, boring number. What is a better and easier way to write this number here, this multiplication? What's a better way to rewrite this as an exponential expression instead of this whole thing?
7 to the 5th, right?
Exactly, the base, and is repeated 1, 2, 3, 4, 5 times. So that's what exponents are. It's just a way to write multiplications easier and faster. Okay, let's now move on to the order of operations. We're going to be using this in that. Operations are basically addition, subtraction, multiplication, and division, and exponents as well. That's one of the operations. So basically, when we have multiple of those in one expression, we need to know how to solve them and in which order. For example, if we have 3 plus 2 times 4, so this has to be done in a specific order. Which operation is done first? So we have addition, we have multiplication. Which one do we do first? If you have to simplify this.
Multiplication.
That's right. The multiplication has priority over the addition. Then you do the addition, we get 11. So the operations are all summarized in this acronym. We could have not just these two, we could have a bunch of operations together, including parentheses, division, multiplication, and exponents. We always perform the operations in this specific order. We start with a P, which stands for what operation is P? Not an operation, but the symbol. That means parentheses.
Yeah, parentheses.
That's right. Or sometimes brackets like this. The E for
Exponents.
that's right. The E is for the exponents. That's what we explained. So those are part of the order of operations of exponent. And of course, M.
Multiplication.
That's right. Then
Division.
okay, and
Addition.
addition, and finally
Subtraction.
subtractions. That's your order of operations, starting from here and going this way. There's a little special case when we have multiplication and division together, when we have addition and subtraction. If you have these two next to each other, you do left to right. Whichever one comes first. If this one comes first, you do it. If this one comes first, you do it first. So left to right. Same thing with these two. If these two are directly next to each other, you do left to right. And we'll see examples of that. Okay, so it was pretty simple. Let's see another one. So sometimes you may have, like I said, these two next to each other. So you may have, let's say, 12 divided by 6 multiplied by 3. So we have two operations from these. We have division and multiplication. If you look at the order here, you may see that the multiplication comes before division. So you might be tempted to do this one first. You might be tempted to do multiplication first, but it's not the case. When these two are together, remember, do whichever comes first. Whichever comes first, left to right. This one comes first, so we're gonna do this one first, not the multiplication. So that's first one here. So that would be 2 times 3. Then the multiplication will be 6. Not the multiplication first, even though you see it here, but if they're together, we do left to right. Same thing happens with when you have addition and subtraction next to each other. You have 7 minus 2 plus 4. Same thing. Which one is done first here? Which operation do we do first in this one?
Addition, right?
Even though, so again, these two here, when they're together, we do left to right. Whichever comes.
Yeah, okay, my bad.
Okay, whichever comes first here in the expression. So that.
Subtraction.
That's right. 5 plus 4, that's 9. Okay, so be careful with these exceptions here. Only if they're directly next to each other. As we go, the expression or the arithmetic expression is going to get longer and longer with these, multiple of these. And every time we have to figure out which order to simplify. And it's adding some more numbers now. 2, say times 3 to the second. And then do maybe minus 5. Always try to identify your operations first. So it looks like we have a multiplication, we have an exponent, we have a subtraction. And this is the order in which we have to simplify. All right, so what is done first here? What do we do here in this expression?
Exponents.
That's right. So we don't have, so you look for parentheses, we don't have them. You move to exponents, then the multiplication. So it's not 2 times 3 yet, because the exponent comes first, as we saw in the orders.
9 was 9 times 2, 18 minus 5 is 13.
That's right. The exponent first, then you look for multiplication, which is here, before the subtraction. So that's 10 to equal 5, which is 13. And that's your answer. Again, it's not the multiplication, it's this one first. Now let's throw in some parentheses and see what happens. So let's say you have 5 multiplied, say, 7 minus 4 to the second plus 1. As you can see now, it's getting a little more complex as we put in more numbers and operations. Again, always look at these and try to determine all the operations. So we have a division, we have parentheses, subtraction, an exponent, and addition. And you don't have to think too much about it, or you don't have to invent anything. You just have to go by the order of operations. Follow this letter by letter. So look for parentheses first, and then exponents, then multiplication, division, and so on. So what do we do here first? In this expression.
Parentheses.
That's right. So we're going to do the parentheses first, inside of them. Only the parentheses. Everything else will stay the same. We just bring everything else down. So 7 take away 4, that's 3 to the second plus 1. Keep everything else the same. Do one thing at a time. What comes after the parentheses?
Exponents.
Exactly, so exponents here. So that's 3 to the second, which is 9. Again, everything else should stay the same for now. So we did the exponent. After the exponent, we have division, addition, as you can see here. Division comes before addition. So we're going to do that first. Unfortunately, this is, we don't want to have a fraction, so to make things convenient, we're going to turn this into 45. 45, just so we don't run into fractions, 45. And now we have division addition. We're going to do the division first. What's 45 by 9? 45 by 9 is it's 5 plus 1, and finally that's 6. So we did the division here. Finally, the addition. That's the specific order. So everyone, when you do this, you get the exact same answer. You cannot be a different answer from one person to the other. We have the same order, so the answer needs to be the same as well. Okay, so that's that. Let's look at another problem here. I'm going to put in a few operations as well. So you have 12 plus, let's say, 3, 8 minus, let's say, 5 to the second power. And we can even add in maybe a division. Okay, so if we take this here, it will be 3 to the second. It's 9. We can divide this possibly by 9, for example. Okay, so we have a bunch of operations here. So that's pretty good. Okay, so it's more than the previous one. Where do we start from again?
Parentheses.
Always parentheses. So evaluate that. So it's going to be 12 plus 3. Only one thing at a time. That's 3 also to the second divided by 9. You make sure you write the whole line every time. It makes it easy for you to see and follow, not just what you evaluate. Try to repeat the whole thing every time. Of course, after the parentheses, we're going to evaluate from all these.
Wait, what was the question?
After the parentheses. So
Oh,
now,
exponents. Exponents. I'm sorry.
very good. Turns into 9. 3 to the second is 9. We have 3 here plus 12, 5, 9. So we evaluated the exponent. After the exponent again, we have multiplication and division, but pay attention if they are next to each other.
Go left or right?
Left or right. So we have multiplication and division. So left one first. So that's 27 divided by 9. Bring down the 12. And continue with all the operations. So we did the multiplication here. Now we can do that division that's left, which is here. Bring the 12 down again. 12 plus 27 divided by 9. That's 3.
Yep.
Right? Finally,
Mm.
the addition will be 50. Okay, so the order is basically universal everywhere. It's the same thing, same method. Math is a universal language. It's the same everywhere you go. That's that. Let's see now another problem. This time maybe with fractions. It's possible to have a whole fraction with two order of operations. Let's say you may have 2 and 7 minus 6 minus 1. And here you may have another one, let's say 3 to the second times 2 minus, let's say 15. You can even add a power here, maybe. Let's add another power here. So when you see something like this, it's pretty much the same thing. So this one, we simplify, say using the same order as here, PEMDAS. Then you go back to the bottom and you repeat the same thing. So each one has its own order, but we can do them at the same time. They're independent, but we can do them simultaneously. Okay, start with the first one here. As always, I'm gonna do
Parentheses.
7 take away 6, that's 1, to the third minus 1. So when you go to the bottom, you start a new order for just the bottom, for the numerator. So exponent, multiplication, division, subtraction. Which one is done first?
Exponent.
Exponent, right? That's 9 times 2 minus 15. And then you go back to the top and continue with the order you started. So we do multiplication now. Which one is done after the parentheses?
Yeah, you gotta do the exponent.
Exactly. Before the multiplication, we're gonna do this. 1 to the third is 1, 1 times 1 times 1. Any power, even to a power 100, is always 1. When you times 1 by itself, you get the same thing. 1 to the power 188 is always 1. So because you just times 1 by itself. So 1 to the third is 1, not 3. People sometimes by mistake 3, but it's not. So that, come back here, multiplication, subtraction. Of course, the multiplication, then take away. Finally, still have two operations here, so we're going to do the multiplication. 2 times 1 minus 1 and over 3, which is 1/3. Okay, so you may end up with a fraction here, or sometimes it could be a whole number, that's not a problem. But the way you do it is similar to these, you just have two of them. If you want to do them separately, that's fine too. If you want to work on this one by itself, and then work on the other one on the side, and then put them together as a fraction at the end, that's fine as well. Either way, you should get the same result. Okay, so that's what happens when you have that. Let's now see the case where you have parentheses embedded inside parentheses. So let's say you have 5 plus 2 times, let's say 8 minus 2 to the third plus 1. But actually, let me put some parentheses here too. Let's say you have 2 or 3. 7 minus 5. 7 minus 5, and let's say minus.
I got a question, but I'm gonna ask you when you finish right now.
Okay. All right, go ahead.
Okay, with this one, like, are we supposed to do ones inside first, or are we supposed to, like, the parentheses inside?
Okay, so That's right, we do the inside first. So when you have, basically the reason why we use brackets, because we have parentheses inside. So you have parentheses inside, you don't want to use another set of parentheses. You can still use them, but it's better to use brackets. That way you can easily tell when it starts and when it's finished. If you have a parentheses here, you wouldn't know, does it end here or here, so it can be confusing. But with brackets, you can easily see what's inside those brackets. Basically, we're going to work inside the whole thing here, the whole brackets. All of what's inside will be simplified. Addition will be the last thing, so you don't want to add 5 and 2. Again, the order of operations, addition is the last thing next to the subtraction. So you want to work inside of the brackets. Everything else should remain the same. So 5 plus 2 doesn't change for now. So when you go inside the brackets, inside of them, we also apply the order of operations. So inside of these, we start a new order of operations. So what do we do first here?
You do the outside brackets, right?
We work in the inside now. So inside of the brackets inside,
yeah.
we're going to apply the order of operations. So here, PEMDAS applies even inside. So we're going to do the parentheses first inside of this. Yeah. Okay, so it will be 2 minus 10. We're going to have to simplify this completely before we do the other operation. So this is 5 plus 2. So 3. We have multiplication and subtraction. So we're going to do the 6 minus 10. Again, I don't want to run into a problem like this. So let me turn this into a 1. We haven't done the rules of signs yet. I don't want to run into a negative. So we have 13 times 2, that's 26, minus 10. Last operation inside the brackets will be the subtraction. So that's 16. Finally, we're down to 2 operations. We have addition here. What is the operation here between the 2 and the brackets?
Is that multiplication?
That's right. Just like with parentheses, it means it is a multiplication in between. Evaluate this first. So 5, bring it down. 2 times 16, that's 32. Finally, that's 37. That's how you deal with this. If you see larger parentheses, basically, those need to be done first as you go. So throughout this, we worked with brackets, brackets, brackets again. Finally, we did the multiplication here and the addition at the end. Okay, so it doesn't matter how long or how complex the expression might look. You just follow the order of operations to simplify. Okay, you guys all right?
Yes, sir.
Okay, James, good. Maricela, Pavel, you guys all right? Maricela, Pavel, you guys let me know if you have any questions. Let's see what else we're gonna do here. So this also applies to fractions. So far we've used only integers or whole numbers. The same order applies to fractions. So you take, say you have 1/6 added to 2/3 times 5/2. Again, still just an arithmetic expression. We can do that. We can simplify it using the same order here, the order of operations with fractions. We've learned fractions in the first couple of classes, so we know how to do all the operations. In addition to the order of operations, we can simplify this problem. So where do we start from again?
Multiplication.
Exactly, so we're going to multiply these first. we already know how to do the multiplication. So we can reduce by 2 first. So we're going to have 1 here and 1 here. So 1 times 5, that's 5. Over 3 times 1, that's 3. As always, simplify your multiplications before multiplying. Now we're down to 2 operations. What happens next? Can we add these two right away?
Which ones?
These last 2 fractions.
I think so. I'm sure.
We need the additional fractions. We need to have the same denominator.
The same, oh yeah, the same one. The same denominator.
That's right. So what's the common denominator here? 6 and 3.
6, right?
That's 6. So we have 6 here. We need to turn this one into 6 by 2 times by 2. And of course, that's 1/6 plus 10 over 6, which is basically, add these two, 11 over 6. What kind of fraction is this?
Improper.
That's right, improper. So we can say, turn this into a mixed number. 6 into 11, how many times?
Once.
That's right, 6. And the remainder will be, from 11, it would be 5.
Yeah. My bad.
Okay, so if you see a bunch of fractions, again, just think about the order of operations to know what to do first, and then think about the operations of the fractions themselves. We learned all of them, so you guys should be familiar with all of that. You may also have parentheses in them. Say this plus actually, let's make this maybe 11. And maybe some other number here. 1/2. So we have 1/2. We have times. We have the parentheses. So again, we're gonna have to start from the parentheses. So 1/2 multiply. Luckily, we have the common denominator. We can just subtract 11 take away 3. That's 8. There, that's 1/2. And again, there's a couple ways to do this. You can simplify this. 8 by 4, that's basically 2. Okay, 8 by 4 is 2. We can turn it into a fraction like this. Finally, times these two. You can cancel the 2's again. What you can times first? If you multiply 2 by 1, and again here,
Once.
should be 1, okay? So, same order of operations applies to fractions. Also applies to decimals if you have decimals, which we talked about last time. Same thing, if you see them, just follow the order and then perform the right operation. We did everything with decimals last time. One more example with fractions here. Say we have 2/5. We want to divide that by 1/10 and multiply that by 1/3. Okay. Again, no reason to panic when you see a bunch of fractions. We already know the order of operations. We just need to apply it. So where do we start from here?
Division? Yeah, not the multiplication. Yeah, it is division, left to right.
That's right. Just gonna start on division. Then recall the steps of multiplying divisions. What is the first thing you do to multiply or to divide fractions? Or how do you multiply fractions? Again, we saw this in the class.
Ain't this keep change flip?
Exactly right. So we're gonna keep change flip, keep the first one, change this into a multiplication. We flip the second one, 10 over 1. Bring this one down here. At this point, we have all multiplications. You can continue finishing this one and then multiply by a third, or you can do all at once if you want. That's fine too. You can do 2 times 10 times 1, which is 20. 5 times 1 times 3, that's 50. Because they're both multiplications, we can do them at the same time. Can we simplify this fraction?
Yes.
Okay, what goes into both numbers here?
1 time.
5 times, that's right. We reduce by 5 will be 4. Reduce this by 5 will be
Wait, what?
3, right?
Oh yeah, my bad.
5 goes into both, okay. And again, this is an improper fraction. You can say 4 and 1/3. 4 into 3, sorry. 3 into 4, how many times? 3 into 4 goes once. 3 into 4 once. You bring the same denominator, and the remainder will be 1. So 1 and 1/3. That's how you do your order of operations with fractions. You can, like I said, do the same thing with decimals. Let's see. So let's see, here we have next thing is to use some word problems. So you may have a problem in a sentence as a sentence, and then you translate it first into this before you use the order of operations. So let's translate that, or do the translation. Problems. As we saw before, last time we talked about the word problem, the expressions can be written in different versions or different ways, but the translation can be the same when we want to solve them. Let's say twice 3, say twice 3, decreased by, let's say, so that's an order of operation, but it is written as a sentence instead of a word problem. So first, before we use the order of operations, we want to translate it. Hopefully you write it in arithmetic form like this. Then we use the order of operations to simplify. So twice 3, what do we mean by that? If you write this in numbers and symbols, how do you exactly write this twice 3? Just 2 times 3, right? Twice 3, or twice a number, it means that number times 2. 2 times 3, decreased. The keywords here are these. Decreased, of course, means, what is decreased for? Subtraction. When you decrease something, decreased by 7, then added to 6, plus 6. These are exactly the same, just written into different forms. Now, I'm going to use order of operations to simplify this. Which operation is done first again? Everybody, what is the first operation?
Multiplication.
Try multiplication. Bring the other two down. Then now we're down to two operations: subtraction and addition. Which one do we do first? According to what we said earlier. When we have these two together, which one do you do first?
Addition.
Not necessarily addition, but left to right. Okay. When you have addition and subtraction together, you want to do left to right, whichever appears first out of these two. So left, then right. So this one is, so 6 minus 7 is -1. We're going to talk about the signs later on. Plus 6. Now we can do this addition here. So -1 plus 6 is +5. Don't worry about the signs too much for now. We're going to spend the whole class talking about all these signs here. This is basically the point here is just to translate all your operations using the appropriate word. Each word has an exact equivalent operation, so you want to make sure you translate that accordingly. Decrease, increase, add, subtract, or all the variety of those words. There's a bunch of them, so make sure you use the right ones when you translate. In the book, you will find a list or a table of all those keywords that you can use, the keywords for the order of operations. What else? Let's do one more problem. So find some other keywords here. Basically, it could be any number, all the commonly known words that refer to the operations. Let's say the quotient. Quotient of 21 and 3 multiplied All right, so let's translate this together, quotient. So keyword is quotient, of course, multiplied. You know what that is. What do we mean by the quotient? Or what is the operation for that? What do you mean the quotient of two numbers? What does that mean? What operation between the two numbers? Quotient stands for, or the result of division. Quotient is a result of division, so the quotient of, that means there's a division. There's two numbers. The numbers are 21 and 3. And of course, multiplied by, can use a multiplication, and 2. And again, how do you simplify this? What do you do first? Are you guys here? Are you guys want to learn something? You want to participate?
I'm here.
I mean, I know James, you're here. Maricela,
I'm
Yeah, I'm
here.
here.
you want to pay attention and learn some math, or you want to be on your phone the whole time?
I'm taking pictures and I'm taking my own notes.
Okay, so you can engage now, and you can. I'm gonna post this to the folder, you can rewatch it later. I know you mentioned before that you need help with math and stuff, so please pay attention and learn something. So we have division, we have multiplication. And which one do we do first according to the order we talked about earlier?
We'll go from left to right, so we would do division.
Exactly. 25.
Divided by 3.
That's right. So this will be
So
7 times 2 and 14. Okay, so when you see word problem like these, translate them. Be careful with the keywords, increase, decrease, added, subtract from, product, and so on. One other example.
you put on the microwave. In the microwave because you have to heat it up.
3 times this, the difference, rather. Difference of okay, 3 times the difference of 5 plus 12. This one's a little tricky, so let's try to translate this correctly. So 3 times the difference of 7 and 5, and the whole thing plus 12. Especially this part here, 3 times difference. How do you translate this first part? 3 times the difference. It's going to be 3, okay, and then times. Then we have difference. How do you write that? Are we going to write on minus again? It's not good.
I thought that was a minus.
So okay, 3 times the difference. Difference means minus. So how do you difference of 7 and 5? How do we write that after this?
3 times 7.
7 to the 5th power?
Nope, this is the difference, subtraction. Difference of 7 and 5. 7 minus 5. So this is
Two?
You're going to put it in parentheses.
exactly, you're going to need parentheses. So it's 3 times the sum or the difference, whatever it might be, that needs to be in parentheses. If you don't put parentheses, this looks like 3 times 7. It does not say here 3 times 7. It says 3 times the difference of the two. It means 3 must be multiplied by whatever this is, a difference. So that thing should be in parentheses. So this is a difference. And of course, the whole thing plus what is added to 12. And now we use order of operations again. So parentheses first, multiply. That multiplication sign is unnecessary, but you can just write it like this. Here we have 2 plus 12. Now the multiplication, then the addition, 6 plus 12, that's 18. Okay, the final answer here is 18. And that's pretty much the order of operations. It applies to all sorts of numbers, whether they're whole numbers or fractions or decimals. PEMDAS is the same order that applies to them. And for translations, be careful with the keywords and also the order in which these keywords are written. Make sure you translate. If you don't get the right expression, of course, the answer will not be right. So make sure you get the right translation in order to get the right answer. I believe that's pretty much it for the order of operations. There's going to be plenty of practice problems in the homework, very similar to this.